Okay, good morning students. So last class the discuss about the topic is so what is the isothermal process and what is the adiabatic process. So isothermal process so means so that is the temperature that is means the pressure and volume is changes at a constant temperature is called as a isothermal process. In adiabatic process, so now today discuss about that adiabatic process. So adiabatic process, in this process, so the changes in a temperature, and volume. Okay, so temperature of the gas is taking place. So temperature of the gas is taking place. So in a thermally isolated system, thermally isolated system. So that is called as a adiabatic process. So what meaning of the adiabatic process? So change of the temperature and volume. Okay, pressure is also changes, but at constant thermally. Okay, so constant thermally of the isolated system is called as a adiabatic process. Okay, got it. So in the last class we discussed about the work done by the gas in a adiabatic process and is also in isothermal process also. Okay, got it. So now today discuss the work done by the gas. Okay, so work done in a adiabatic process. Okay, so the work done by the gas, so the during that means so first of all, so the gas is a expansion in a adiabatically process. So the gas is taken, the pressure is P1 and volume is V1 and absolute temperature is taken T1 initial state. Okay, so the pressure P2 and volume is T2, absolute temperature T2, so goes to final state. Okay, so the gas is expands adiabatically. The gas is expansion in adiabatically. Okay, so here taken, so that work done by the gas during the small expansion in a volume, the volume is changes V1 to V2. The volume is changes V1 to V2. Okay, so the work done, it is we can write W is equal the small work done. Okay, small extension, small work done. So dW is equal, we can write the equation P dV. dW is equal P dV. Okay, got it. So right, so the PV is equal PV to the power of gamma is equal to taken constant. So the gamma is a specific heat of a gas, the ratio of the specific heat of a gas. Okay, so the PV to the power of gamma is equal to constant. Okay, so the gas is expansion adiabatically in a small extension. Okay, so that is the dW is equal to P dV. Okay, P dV. So the PV to the power of gamma is equal to constant. So gamma is a ratio of the specific heat of a gas. Gamma is a, so here taken gamma. So the gamma is a ratio of the specific heat of a gas. Okay, got it. So PV, that means W or dW or delta W. So delta W or dW is equal to P dV. Okay, so that is the PV to the power of gamma is equal taken constant. Okay, constant. So P is equal to K by V to the power of gamma is taken. Okay, so now substituting in the equation, so dW is equal to K by V to the power of gamma dV. Okay, so K by V to the power of gamma dV. Now we have taken total extension. Okay, total extension that will get total work done. Okay, work done. So during the total expansion. Okay, so taken integration on both sides. So integration of W is equal to integration of dW is equal to W. Okay, so integration of dW is equal to, so dW is equal to K by V to the power of gamma dV. K by V to the power of gamma dV. So the limitations are taken. So V1 and V2. V1 and V2 are taken limitations. So some constant is taken outside. Okay, so the remaining equation, so V1 and V2, V to the power of gamma is go to. Okay, so in upward, so that is nothing but we can write V to the power of minus gamma dV. Okay, so now general equation we can write x to the power of n, integration of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 we can write. Okay, got it? X to integration of x to the power of n dx is equal to x to the power of n plus 1 by, we can write the in a denominator, that is the n plus 1. Okay, we have taken integration of dw is equal to w, integration of dx is equal to x. So we can write in a general equation integration of dx is equal to x. Okay, integration of dw is equal to w. So the work done is taken limits from v1 to v2. So the dw is equal to, so the integration of v1 to v2. So the dw is equal to, already we know that. So the k by v to the power of gamma dv is substituting, and k is taken outside of the integration. So v1 to v2, v to the power of minus gamma dv. So just for example, so the integration pattern is applied. So the integration is taken x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. Now here substituting, the w is equal to k, so integration v to the power of minus gamma. So v to the power of minus gamma plus 1 by v to the minus gamma plus 1. Okay, so the limits are go to outside v1 and v2 is taken. Okay, so the w is equal, total work done is equal to k, so v to the power of minus gamma plus 1 by gamma plus minus gamma plus 1. So taking the limit after integration, so go to outside v1 and v2 is taken. Okay, so now substituting upper limit minus lower limits. Okay, now substituting upper limit minus lower limit at the place of, okay, at the place of v. Okay, so here taken, so k by 1 minus gamma we can write. So minus gamma plus 1 we can also write, so 1 minus gamma. And so substituting in the equation, so v2 minus gamma plus 1. V2 minus gamma plus 1 and minus V1 minus gamma plus 1 is taken. Okay, so V2 is substituting 1 V plus minus and lower limit or substituting upper limit minus lower limit. V2 minus V2 minus gamma plus 1 minus V1 to the power of minus gamma plus 1. Okay, got it? Now okay, so W is equal to, here taken, so K is go to inside, is taken to inside, so the W is equal to, W is equal 1 by 1 minus gamma into K, so K V2 to the power of minus gamma plus 1, so minus K V1 minus gamma plus 1. Okay, so now we can write the general equation. So that is called as a, we have taken P to the power of gamma is equal to constant. If in case of, okay, so P1 V1 gamma is equal to, so P2 V2 power of gamma is equal to constant. Here taken, so V2. So the K value is taken, so V2. P2 V2 power of gamma and substituting in a K place. So W is equal 1 by 1 minus gamma and so the K value, that is nothing but we have taken P2 V2 to the power of gamma. P2 V2 to the power of gamma into V to the power of minus gamma plus 1 minus, so K value is taken P1 V1 to the power of gamma 1. So P1 V1 to the power of gamma V1 minus gamma plus 1. Okay. So W is equal to 1 by 1 minus gamma. So here is taken or divided in two parts. So the P2 V2 to the power of gamma and V2 minus gamma and V2. Okay, so P1 V1 to the power of gamma, V1 minus gamma and V1 is taken. Okay, so here taken, that is means x to the power of a plus b is equal x to the power of a into x to the power of b. Now we have taken these two terms are cancelled. So the remaining here also cancel. Okay, so the remaining equation we can write. So W is equal 1 by 1 minus gamma. W is equal 1 by 1 minus gamma into P2, remaining term you can write V2. We have taken minus P1 and V1. Now we have taken ideal gas. So ideal gas equation, so PV is equal to RT. PV is equal to RT. That means P1, V1 is equal to RT1. P1, V1 is equal to RT1. And P2, V2 is equal to RT2. Okay, now these two equations are substituting in the equation. Okay, so W is equal to 1 by 1 minus gamma and so P2V2 means R T2 minus R T1 are substituting. So P2V2 plus substituting R T2. Okay, so minus RT1, R is taken common, R by 1 minus gamma, T2 minus T1, so W is equal. Now we are considered only 1 mole of the gas. So number of the moles are taken, so we can write that equation. So W is equal mu R by 1 minus gamma, so gamma minus 1, so T1 minus T2 we can write. Okay, so 1 minus gamma, T2 minus T1. So gamma minus 1 we can write T1 minus T2. So the total work done in adiabatically process. Okay, totally work done by the gas in adiabatically process. So the W is equal to mu R by gamma minus 1 T1 minus T2 we can write. Okay, got it? Right. Okay. So in isothermal process and adiabatic process. So what meaning of the isothermal process? So isothermally process. In this process, the temperature and that is pressure is changes and volume is changes at a constant temperature. So that is called as a isothermal process. But in adiabatic process, so the temperature changes and volume changes and absolute temperature is also changes, but isothermally. Okay, isothermally, so taken the system is remains constant. That is called as a adiabatic process. So now we are taken, so some differences are taken in a isothermal process and adiabatic process. So in isothermal process taken, the temperature is remains constant. That means delta T is equal to 0. Okay, in isothermal process the temperature is constant. Okay, so that is called as the process is called as a isothermal process. But in adiabatic process is taken, so the heat is constant. Okay, heat is constant. So the heat is remains constant. That we can write. So the delta Q is equal to 0. But here taken delta T is equal to 0. Here taken delta Q is equal to 0. Okay, in isothermal process. Changes, the process it changes occur slowly and here taken very suddenly and very quickly process. Okay, and so now another taken difference. So the internal energy U remains same or constant, that we can write in mathematical form. So the delta U is equal to 0. Delta U is equal to 0. But here taken, so the internal energy is changes in adiabatic process. Internal energy is changes in adiabatic process. Okay, that delta U is equal, not is equal to 0. Okay, so now another taken equation in a isothermal process. Okay, so that PV is equal to constant in isothermal process. So equation we can write, so PV is equal to constant. But in adiabatic process, so the equation we can write PV to the power of gamma is equal to constant. So the gamma means the ratio between, okay, the ratio of the specific heats. Okay, so ratio of the specific heat of a gas. Okay, here again PV is equal constant, but here PV to the power of gamma is equal constant. Okay, so specific heat become infinity. Specific heat become in infinity. Okay, in isothermal process, but in adiabatic process, so the specific heat is 0. Specific heat is 0. Becomes here heat is also 0. So specific heat is also 0. But here taken infinity. In isothermal process, infinity. But in adiabatic process, the specific heat is taken 0. Okay, so got it, right? So further discussing in next class. So what is the new thermodynamics second law? Okay, so thermodynamics second law. So what is the cooling law? Okay, so discuss in a further classes. Okay, thank you, students.